Yes, sir. On the diagram.
Okay. So we have understood. Uh, we have understood the not understood. We have known the names of various structural components. Now, what we try to do is we will try to dive a little deeper and understand how the bottom structure looks like, and how, or rather I should say how the bottom structure is different in transverse framing and longitudinal framing. Okay, now one question: can we have a is it correct to say that we can have a combinationally framed double bottom? Is it correct? Was that a yes or no? Please tell me. Guess कीजिए. You can always guess. No guess. Okay. But we are connected, right? Yeah, I'm audible to you still.
Yes, sir. You are audible.
Okay, okay. ठीक है. So actually, it is not correct to say that we can have a combinationally framed double bottom, because when we say combinational framing, we talk about different. We talk about the entire ship. That means we have the bottom, the double bottom stiffened longitudinally, and side shell is stiffened transversely. So we cannot have a combinationally framed double bottom. The double bottom is either framed longitudinally or transversely. Okay, those are the two possibilities we have. Those are the only two possibilities. Now, let's move on. Let's look at a longitudinally framed double bottom. Now, this text part, you read them later. I will just explain you what all things are written and what all things we need to understand. Now, what we have here is a longitudinally framed double bottom on the left, whatever we have. Now, let me see. They have given you a very simple diagram, rather. Okay. You can draw a simple diagram. Is it okay if I show you a little complex diagram? It will help us in our understanding. Is that okay with you?
Yes, sir.
Okay. So let's understand what we are seeing right here is a longitudinally framed double bottom. Okay. What we are seeing is we have the bottom plating. We have the center girder. That means this is the keel plate we are looking at. Okay. And we have quite a few side girders depending upon the breadth, because we do not want the unsupported span of the floors to be more, so we have to support them. We have quite a few depending upon the breadth. Here they have shown one side girder. Okay, and then we have the transverse floors in place. Okay, along with that, because this is a longer ship, we are worried about the bending moments. We have bottom longitudinals and we have inner bottom longitudinals also. Okay, these ones which would have extended. Okay, these ones on the top. Now, these floors, if you remember, we talked that in the very initial class, while talking about framing system, we talked that plate is stiffened if it is stiffened in this manner and in this manner. This is the basic concept of stiffening any structure. Similarly, these floors that you see, these floors are transverse members. Now these transverse members, they have girders fixed, some side girders to help them. But always remember that these floors, they will have some more stiffeners as well. Sometimes they will have angle bars welded like this, or some flat bars may be welded. And these stiffeners, which are welded on the floors, are called as struts. Okay. Now, this is all that is about longitudinal structure. Now we will jump a little deeper into these components and how these components are placed. Okay. So, first of all, talking about the keel plate. The keel plate has three different configurations. Okay. Let me go to your different slide, this one. Let me show you some varieties of keel. Okay. Okay. We have three different types of keel. Yes. This is not in your syllabus. I'm just telling you. The first type of keel is a bar keel. Bar keel means we have a solid steel bar which is fitted at the center. Sometimes if you go to beach, you will see that those small fishing boats, something, the fisherman will come, then he will drag the boat on the sand itself. Have you seen that? Anyone?
Could you repeat the question?
Okay. Sometimes on beach, when you go, you will see that some fisherman will come. He will drag the small boat which he went on the sand itself. Have you seen such a thing?
Yes, sir.
Yes. Now, in such vessels, you will notice that they will be having a bar keel. These bars are heavy and strong also. When a vessel is meant to be beached kind of thing, that means they will be dragged kind of thing on the sand. Those types of vessels will prefer having a bar keel. This type of a keel is not present on any merchant vessel that you'll be sailing on. Okay. Now, rest of the things are very similar. We have the other strakes. Now, since this strake is adjacent to the keel, it is called as a garboard strake. Okay, but this is a single bottom ship. This does not have a tank top, which is why we have a keelson. A keelson is basically a plate which kind of keeps all these floors in place. Okay, we don't have to discuss in detail about this, but remember, this is a type of keel, but used for very small vessels, not for big ones. The second one. The second one is a plate keel. Plate keel is very widely used and it is very strong also. But in this diagram, there are a few mistakes. Like the keel plate, let me try to remove this. This is not the keel plate. Okay. The keel plate is this one. This plate is the keel plate. Oh God, this still looks. Actually, the difference is these tablets and computers, they have different number of pixels. So whatever I erase on the tablet, it is still visible on the computer. Okay, so this is a keel plate. Now, what you are seeing here is this is our centerline girder. We have the floors in place and side girders are not shown. And on the top, we have the tank top. Okay. This kind of a configuration is very strong because when you see from this side, you see a I-beam kind of structure. Now, a I-beam is very resistive to bending. And the bottom structure of the ship is designed to resist hogging and sagging. Okay, so this is a very good configuration. But here, all these places will be flooded because it is double bottom tanks. So that becomes a problem sometimes. We want some dry space. So what we do is the third kind of category is duct keels. Here, basically what we have done is the same arrangement. But instead of having one centerline girder, we have two girders. So since we have two girders close to each other, in between that we have a hollow space. And that hollow space is not used for ballasting. It is dry. It is kept dry. So we can take our piping, cable, anything through that. So in this case, we have two girders. These are not actually keel plates. This is a mistake. These two are girders, and entire thing is actually a duct keel, I can say. Okay, we have the floors in place. We have the bottom shell. Because the strake is adjacent to the keel plate, I can say that these are garboard strakes. And on top, we have the tank top. Okay, is this understandable, these three different types of keel?
Yes, sir.
Okay, now just to take it a little further, this is a riveted ship. Actually, we do not have riveted ships, but this is how the bar keel looks like. We have a solid bar in the bottom. In plate type of keel, simply it is a plate. Okay, and duct keel, we have just made an enclosure. That's it. No other difference. This duct we format to have our piping cable something, and this duct, whenever we have a duct keel, we will provide some access in it. That means, as we are saying that duct keel will help us with our inspection or repair work. Now, a person will be able to do the inspection or repair when he has good access to. So usually in ships, they will have a small track kind of arrangement, like a railway track kind of thing, the way they will be there. On that, there will be a basket kind of thing, and people can sit in and they will have a rope kind of arrangement. They'll pull the rope and they will go ahead and they will come back kind of thing. So they have a arrangement like that. Now, once this is done, let's look at let's see this. What we are seeing here, basically what I'm trying to say is this figure that we saw, this one, when represented in 2D, from exam point of view, you will be drawing this figure. Okay, I'm just showing you a slightly different configuration. That's it. Now, what you are seeing here is a longitudinally framed double bottom. In this, let's understand why we have two pictures and everything. First of all, these transverse plates that I have added, those are the floors. The first thing is, how many types of floors do we have? Do we have only those plate type of floors or not? The answer to that is, there are three different types of floors. Okay. One is called as solid floor. One is plate floor, and one is a bracket floor. What is the difference between them? Solid floor means, as the name suggests, it is a solid plate. It is a solid plate. Now think of it this way. In the double bottom, we say we have ballast tanks or any tanks for that purpose. So these tanks, they have to have some boundary somewhere. Whenever they need to have a boundary, that means in that case, we cannot have these openings as they are represented, isn't it? If we have openings, how is it forming a tank boundary? Am I clear?
Yes, sir.
Yes.
So,
So
sir, what are these openings for?
we will come to that. After talking about three types of flows, we will come to those openings only. Okay, give me some time just.
Okay, sir.
Yes. So, but this is understood, right? If we have a tank boundary, we cannot have openings. Yes.
Yes, sir.
Yes. So in that case, we will make use of solid floors. Okay. Now, suppose the tank, suppose that particular floor is not forming a tank boundary. We can have various openings in that. That means same solid floor with a few openings in it. That type of floor is called a plate floor. That means the floor that we are looking here in the top diagram is a plate floor because it has a few openings in it. Now, solid floors are heavy and strong, but we may not want we may not want to put only solid floors throughout the length of the ship because we should not over strengthen a structure. Over strengthening a structure will increase its mass, will increase its weight, which we do not want to do. So, because of that, what we will do is we will put one solid floor or plate floor for that matter. Thereafter, we may choose to put one or two bracket floors. Now, what are bracket floors? Bracket floors are basically little lighter in weight because they are made in this manner. In the top one, we have a floor. The plate, the plate of the floor is of this shape. And it goes the other side also. It has to be disconnected here at the center line girder. So this is the, oh sorry. So this is the shape of this plate floor. If this was a solid one, there would have been no scallops, as I'm showing you right here. This is a plate floor. Now, a bracket floor, on the other hand, is of different type. A bracket floor, it has only a bracket in the corner, and that's it. In between, these dotted lines are actually stiffeners that are welded from the longitudinals to longitudinals. In the top one, in case of plate floor also, these dotted lines represent some stiffeners that are welded on the floor. And these stiffeners are called as struts. These stiffeners are called as struts. And because we do not want heavy solid or plate floors at every frame spacing, we can put a plate floor. Thereafter, we can put one or two bracket floors. And again, we will put a plate floor or solid floor. And the way we saw those ring kind of structures while studying about framing system, the spacing between two transverse members is called as a frame space. So we may not want always to put solid floors or plate floors at every frame space, but there are certain regions in the ship where we will go for fixing solid floors or plate floors at every frame space. Say, for example, the engine room. Because the engine room has massive amount of loads acting, so beneath the engine room, we will not make use of any bracket floors. They will not be able to take the load. We will only go for solid floors or plate floors. Similarly, the forefoot region. If you remember, we talked about the pounding force. Do you remember? Do you remember pounding?
Sorry, sir?
When we talked about stresses in a ship structure, do you remember we talked about pounding?
Yes, sir, I do.
Yes, sir.
So, because that pounding happens in the forefoot region of the ship, so in that region also we will have only solid floors at every frame space, and sometimes putting solid floors at every frame space also may not be adequate. Like in regions of main engine, in those spaces, sometimes we will put even more solid floors. At intermediate frame spacing also we will put solid floors, because that much is the load acting in that region. Is this clear so far? Or
Yes,
any
sir.
part of it was confusing? Okay, clear now. Now, as someone asked, what are these openings in a floor? Now, in a floor, we will have 4 types of opening. Okay. One opening that you see, usually the circular ones. The circular ones are lightning holes. As we already know, a lightning hole is a hole which is cut into a structure to reduce its mass or reduce its weight. The oval ones are the manholes, people to pass through them. Then there comes the other 2 holes, the drain holes and the air holes. Drain holes, as the name suggests, they will allow for fluids to pass through. Okay. But what's crucial is air holes. Let's go back to the other picture. I think we had a better view there. No, we do not have. Okay, we do not have that. So think of it this way. These double bottom tanks, they are filled with liquid. Okay. If they are filled with liquid, suppose because of motions or for some reason the tank is not completely filled, then we will have something called as free surface effect. Am I right?
Yes, sir.
Yes. Now, because of that sloshing, if the water from the other side of this floor comes to this side, so basically the fluid has come to this side, then what will happen is, suppose the liquid was still this portion. When the fluid from other side has come, the air which is trapped in the upper regions, they will be compressed, isn't it? Am I clear?
Yes, sir.
So we do not want that air to be compressed. That's not a good thing. So instead, what we will do is, in the top corners, we will provide air holes. So in such an event, when liquid from one compartment has rushed in, the air will not get compressed anymore. The air can just pass on to the other compartment. The water from other compartment has come here. So air from this compartment through the air hose can pass on to the other side.
So, sir, it is like ventilation only.
Uh, Not exactly ventilation. We don't want trapped air to get compressed. Ventilation is when you need fresh air somewhere.
So, sir, this trapped air would be escaped outside the ship or it would be inside the tank only.
No, inside the same tank only, just on the other side.
Okay, sir.
Because in a tank, we will have a number of floors running. Okay, these floors are like, say for example, perforated walls. Okay, so the air is still in the same tank, only passed on to the other side. Instead of getting compressed, we have given it a pathway that you can stay there for the meanwhile. Okay. Clear?
Yes, sir.
Okay. So these are the 4 types of openings that we have on floors. And we understood we have 3 types of floors. Now, from exam point of view, you will be drawing these 2 figures if at all asked. Okay, we will come to it. The upper one shows a section of double bottom where it has a plate floor, and the lower one shows a section of the double bottom where it has a bracket floor. Which is why if in the exam it is asked to draw a longitudinally framed double bottom, then you have to draw both of these drawings, this one and this one, because this shows that only plate floors are not used at every sections. Rather, we have plate floors or solid floors, and sometimes we have bracket floors. This right here, what you are seeing is the bilge keel. We studied that in the previous class. And yes, and as you know that this particular thing, it represents the connection of the longitudinals with the transverse members, the scallop and the collar plate. Here they have not shown a collar plate. Actually, the transverse member is welded here, but you can always represent the collar plate also. That is not wrong. That is, you can show a stiffener like this, a scallop like this, and you can show a collar plate in this manner also, whichever you like. These are 2 different configurations of attaching or connecting the longitudinal with the transverse member. Is it clear so far?
Yes, sir.
Okay. Do you have any questions to ask? Anything in this figure? What is this? What is that? Anything?
No, sir.
Okay. So, yes. Also remember that the frame spacing is not sacrosanct. In some places where we feel that the stresses may be quite high, we can add floors at intermediate frames also. And always remember, some regions, the arrangement that we spoke about, like one solid floor or plate floor and then 2 3 bracket floors, is not always the pattern. In regions of high stress, we will go for only plate floors or solid floors. Sometimes only solid floors, even no plate floors, like main engine area. Okay, all these things, whatever we discussed, they are written here with some specific dimensions. Okay, so you just go through them. You will not have any problem in understanding any of these things. Okay, whatever is written. The way I just told, if the breadth is more, you will have more side girders. In these texts, it will be written how much more. Those specific numerical values will be there. So that being said, we will look at a transversely framed double bottom also. On the left, what we are seeing is a transversely framed double bottom. In a transversely framed double bottom, imagine that we are removing these longitudinals, that's it. Bottom and inner bottom longitudinals, when we remove them from the drawing, that becomes a transversely framed structure. That means we have lot many floors in place, and the longitudinal strength is taken care by the center girder and side girders alone. We do not have any bottom longitudinals and inner bottom longitudinals. That's the only thing. Rest things are same. We have a solid floor, plate floor here. Here we have bracket floor. Okay, these solid floors will have those vertical stiffeners. Here they have shown in a solid line. In the other diagram, it was represented in a dotted line. Dotted line represents that the stiffener is on the other side. We are not able to see it, but it exists there. In this, they have shown solid lines because the stiffener is on this side. Okay, that is the way of representing things. And these stiffeners that are welded on the floors, or in case of bracket floors, from stiffener to stiffener, are called as the struts. Okay, these are the struts. So these two diagrams are very important actually. I mean, all these four diagrams. For longitudinal framing, you'll be drawing these two. For transverse, you'll be drawing these two. Never draw only one. Suppose in your class test, such a question is asked, the question will be for 4 marks. Please do not skip any of these drawings. I'll be giving you some assignments to actually draw of your drawings and submit purely for your practice. You will be looking at these drawings and you'll be just replicating them. Okay. You all, do you have any practical in the evening?
Yes, sir.
Yes.
So how long do you have theory classes and how long do you have practical classes?
So for today, we don't have any practical.
And other days?
We'll be having our practical from 1st March, while Division 1 will be having the practical from today.
Okay. Okay. And those practical classes will be for how many hours?
So we have only received the schedule for physics practicals for now, and
Okay.
we'll be having them from 4 to 6. It's group wise, so some of them might be having it from 2 p.m. to 4 p.m. as well.
Acha. Okay. No, basically my intention was to know that how much free time you have. Because if you have some free time, then only I will like giving you assignments. I don't want to overburden you, like do this, do that, do this, do that. You need some time for yourself also. Okay.
And
If,
also,
so
yeah,
So you can give the assignment.
yes,
would
yes.
be
So
better
mm,
because the assignment.
yes. So okay, I will plan out which all diagrams we have done so far and which one should be practiced, and we will start doing those activities. Uh, so this is what is a longitudinally framed and a transversely framed double bottom. After the class, please go through those text that is there. It will really help you in the exam. Understanding point of view, there will be no shortage. You will clearly understand. Okay. That being said, this we have already understood the connection of side shell with bottom structure, that is the tank side brackets. This is how they look simply. But never try to draw any figure that is in 3D in the exam. That is not expected. Okay. I've seen some students, they because they have time, they try to draw those complex 3D diagrams and they're good at drawing. But believe me, you don't have to do that. The marks will be given the same, and try to always draw the 3D, no 2D drawings. 3Ds are given only for your understanding purpose. And that's it. Here, we do not have anything that we need to talk about. We already have understood the complete picture. This represents the three different types of flows. That's it. On the front, actually, here there is a mistake. The floor is only the bottom plate, not the full circle, is not the floor. This much is the floor. Okay. This represents a solid floor. Notice that it does not have any openings. These are the ones which we will use for two particular reasons. One reason is we require strength in that particular zone. The second reason is maybe the floor is forming a tank boundary. There is no third reason to why we will use solid floor. Only these two reasons. And here, these vertical ones that you are looking, these are the stiffeners or the struts. These are simply flat bars. Flat bars, they are welded onto it. Because here, the reason we have not added a stiffener like this, is because the floor will not experience a force. I mean, the floor will not experience a stress in that direction. Nothing is trying to bend it in that direction. The floor is taking all the loads from bottom and from top. That is why we have added only vertical struts. Okay. And right behind it, this one is a plate floor. It simply means a solid floor with a few openings in it. Okay. That is a plate floor. And right at the back, what you're seeing is a bracket floor. In bracket floor, what we have is we have brackets. This is a bracket. This is a bracket. Okay. And in between, we just have vertical stiffeners between the longitudinals. Is this clear? All the three different types of floors and the opening in the floors, the four types of opening. Are they clear?
Yes, sir.
Okay.
Yes, sir.
Because IMU kind of loves the topic of floors. They ask this question very frequently about types of floors and openings and floors. So, okay. Now we are done with this. Mm, these are some of the questions. Please do prepare them. Answers to that is there in this itself. Sketch and label transversely framed double bottom. Uses of double bottom tag. Sketch and label longitudinally framed double bottom. Uses of double bottom. Transversely framed. Okay. Parts of longitudinal framed double bottom showing transverse view. Okay. Explain the following: girders, floors, different types of framing. We all know all those things. Girders are basically the longitudinal members of greater scantling, and they are the primary strength members. Okay. The reason sometimes people will ask you what is the difference between girders and longitudinals, because longitudinals are also in the longitudinal direction, girders are also in the longitudinal direction. But girders are very strong and bigger in scantling compared to these little longitudinals. Okay, that is the difference. What are various stresses encountered by a vessel in seaway? What structural members provide longitudinal strength, transverse strength? Okay, this also you know. Different types of stresses also questions are asked in IMU, but this is not part of the syllabus anyway. But anyways, I've given you the slide on different types of stresses. You can write um, about the local loads, the global loads, and you can mention quite a few of them, depending upon how many marks the question gives you. Difference between a girder and a beam, bracket floor and plate floor. Bracket floor and plate floor is not a different, problem. Girder is a longitudinal member, always beam is a transverse member. A girder is a very structural member of greater scantling, beam is a little one. Actually, girders are primary members, beams are not. Okay, coming to peak tanks. Now, peak tanks, the primary purpose of peak tanks is to provide sufficient amount of trim. Do you know what is trim? Are you aware? Tell me a yes or no. I would be very happy.
So could you repeat the question?
What is trim? Do you know what is trim? TRIM. Do you know?
No, sir.
Okay, no worries. So the thing is, do you know what is draft?
Yes, sir.
Okay. Now, a vessel, when it is floating, suppose the vessel is floating here, and then I can say that this is the draft of the vessel, right? Now, this draft, when you measure it in the forward and at the aft, okay, if I take these two drafts, they may not always be equal. If I call this as the draft forward and this as the draft aft, then the draft taken at the aft and forward may not always be equal. Whenever there is a difference in these two values, we say the vessel has a trim. Okay. We say that the vessel has trim. So if the draft in the aft portion is more, we say the vessel is trimming by aft. If the vessel has draft greater in the forward region, we say the vessel is trimming by bow or forward. Is it clear so far? Meaning of trim?
Yes, sir.
Okay. Now, the point comes, why do we require trim? Almost every case, we will prefer having a trim by aft. That means we want the vessel to have greater draft in the aft region. Think of it. Can you guess a reason to that? Why we want such a thing to happen? Can you just give me a moment? Just give me a moment. Okay, I'm sorry. I just had to listen to something. Yes. Now, any guess as to why we require a trim?
So
Did I
for
unmute?
better movement of the rudder.
Better
So
movement of.
so that we know that that the after end is more sunken in the water or the forward end.
Mhm. Okay. Actually, yes. The first reason was good. Second one was also quite close. The thing is, the rudder is a hydrodynamic device. If you keep the rudder in air, it is not going to help. And most importantly, we have a propeller, which is a fan. It drives our ship forward, but it is only capable of doing that when it is in water. Okay. So we don't want that propeller to come out anytime. That is why to keep the propeller submerged at all times, because propeller, if it comes out of water and then goes back, that particular incident can sometimes damage the propeller. We don't want that thing to happen. I think probably you can imagine why it will damage the blades of the propeller coming out. Or do you want me to elaborate on that?
Yes, sir. Could you please elaborate?
Okay, ठीक है. So, have you done swimming?
Yes, sir.
Now you start moving your hand inside the water of the swimming pool. Okay.
Yes, sir.
You're feeling some resistance. With the same force, you bring your hand out of water. Now, the moment your hand is out of water, because you're moving the hand with a particular speed, your hand starts moving little faster. Am I right?
Yes, sir.
Now, with the same speed, imagine putting or hitting the water again. If you hit water with the same speed again, will it not be painful for you?
Yes, sir, it would be.
Yes, exactly the same thing happens with propeller also. When it is moving in water medium, it is moving at a particular speed because it is overcoming the viscosity of water. When it gets exposed to air, it may try to move a little faster, and when it makes an impact with the water surface, there are chances of the propeller getting damaged. We do not want that to happen. We want the propeller to always operate inside the sea, or we want it to be submerged at all times. That is why we prefer keeping trim by aft. Okay, is it clear?
Yes, sir, clear.
Yes. So these peak tanks means we have tanks, two tanks, one in the forward, one in the aft. We will understand this in the next class. We will not start it now. But the use of peak tanks is for balancing this trim. Okay. We will take this up in the next class. We will try to go a little faster. Today we were slow, and we will see. Do you have any questions, or should I stop here?